All right, I wanted to work through this Chapter 1 test review sheet, and I'm just going to go through all the problems, and hopefully this will help you as you prepare. So starting off, the first 5 problems, we're given phrases in words, and we're supposed to translate these into algebraic expressions. So we're looking for keywords that stand for mathematical operations. And so first of all, number 1, 18 less than the quotient of a number and 3. So I would always treat less than, which refers to subtraction. More than is its addition counterpart. I would always subtract off of this other expression that's given. So let's first do the quotient of a number and 3. You can use any variable you want, so I'm just going to let n be my number. Quotient stands for division. So there's the quotient of a number and 3. And then the way I show 18 less than that is just to subtract 18 from that. And so that would be my answer for number 1. Number 2, 4 times the sum of a number and 3. So the sum of a number and 3, that means addition, of course. And then 4 times that sum. So we really need to show parentheses. In this case, this indicates 4 times the entire sum. Without the parentheses, you're just going to be multiplying 4 times the number, but you won't be multiplying 4 times 3. So parentheses are important here. Here's what I was talking about earlier, 9 more than, again, just like you did less than. Let's do 12 times a number. That's 12n, and then 9 more than that would be adding 9 to that product. All right, number 4, the difference, that's subtraction of 9 times a number and the quotient of 6 and the same number. Okay, so the difference, we're going to be subtracting 2 different things, 9 times a number and the quotient of 6 and the same number. Okay, so the quotient division again of 6 and that same number, and then we just need to show that these are being subtracted. So that gives us the difference, or the subtraction of 9 times a number and then the quotient of 6 and the same number. All right, and then number 5, 4 times the square of a number increased by 5 times the same number. All right, so the square of a number means a number raised to the 2nd power. And 4 times that could be written as 4n squared. So 4 times the square of a number, we've just done that, increased by, that's just another way of saying adding to that 5 times the same number. Okay, and so that would be the way to express that phrase using an algebraic expression. All right, number 6, little word problem. Robert's father is 5 years older than 3 times Robert's age, and together their ages combined is 61. Define a variable. So I want you, when you see a problem like this on your test, I want you to pick one variable, not 2. I know there's 2 different people being talked about, but let's just pick a variable. And in this case, I'm going to let my variable represent Robert's age. Because Robert's dad, it's a little bit like what we just did. Robert's dad's age is described as 5 years older than 3 times. So we can start with Robert's age, and we can make dad's age using this variable and using these phrases, 5 years older than 3 times. So we'll start with X being Robert, and then we're going to use this phrase. So 5 years older than, that's another way of saying adding 3 to 3, or adding 5, sorry, adding 5 to 3 times Robert's age. So 3 times Robert's age, in other words, increased by 5, and that will be Robert's dad. Okay, so you see how that works? So notice I did one variable. The mistake that some people make in this problem is they try to use 2 different variables to represent the 2 different people. I want you to use one variable and then build off of that using the words that describe the other person. Okay, so if we put these two ages together, so here's Robert's age, and if I add to his age his dad's age, according to the problem, the sum of their ages, so here I've represented the sum, here's Robert's dad, here's the sum of their ages, and that should equal 61. So I just combine like terms. I solve for x. So x is 14. X stands for Robert's age. And now I can use that value for x, and I can find out Robert's dad, how old he is. So 3 times 14 plus 5. 3 times 14 is 42 plus 5. So apparently Robert's dad is 47. All right, so just a quick glance, the sum of their ages is 61. So make sure that follow carefully what I've done here. Some people will eventually come up with the right numbers. They'll spend a lot of time just trying numbers until they get two numbers that equal 61. Well, my idea here is that can you do this algebraically? So please watch carefully. Set up a variable to represent one of the people, and then use that variable and the language that's provided to represent the other person. Okay, solving equations. We're going to be solving for y. So first I need to distribute -3 on the right side. So that's -6y minus 3. I need to get the y terms on the same side. So I'm going to add 6y to both sides. 12y minus 5 is equal to -3. I'm going to add 5 to both sides to try to get y by itself. 12y is equal to 2. And now I'm going to divide by 12 on both sides. So I'll put my answer up here. It started off as 2 12ths, but I can reduce that to 1/6. And you could check it. You could, if you got time while you're taking your test, let y become 1/6. 6 times 1/6 is 1. 1 minus 5 is -4. Okay, let's see if we get -4 on the right side if we let y be 1/6. So 2 times 1/6 is 2/6. That's 1/3. Okay, so -3 times 1/3 is -1. And then -3 times 1 is -3. -1 plus -3 is -4. So that checks out. All right, number 8, I'm going to distribute -3 to both of these. And -3 times 4/3 is just -4. Combine like terms. 1t minus 3t is -2t. Put t's on the same side, so if we use that little phrase, kill the little one, I'm going to add 2t to both sides. All right, and trying to get t by itself, so I'm going to subtract 3 from both sides. And now I'll divide by 4 on both sides, and I got t is -7/4. All right, very good. All right, now we're solving, we're trying to get r by itself in this equation. Currently the equation is solved for s, and it's a necessary skill, especially when you get into some science classes. You need to be able to take an equation, sometimes a formula, and solve it for a different variable. So this involves PEMDAS in reverse. So what I would recommend is just identify the parts of PEMDAS that are present in your problem. So there are really two that I see. I see multiplication by L. Now I'm talking about the side that contains the variable that you're solving for. Okay, don't really care about the left side. I'm focused on getting this right side so that r is by itself. And so I notice I'm multiplying by L, and I notice that R is enclosed in parentheses. Don't worry about the operation in parentheses, just check off the parentheses. And so I'm going to work through PEMDAS backwards, and so in that order I would undo the multiplication first. And to undo multiplication by L, I need to divide by L. Okay, and that gets me to here. All right, so now I'm just going to go back and reevaluate PEMDAS. And let's see now what I have relating to R. I've got this positive 1, you could think adding 1. So I've got addition, and I've got multiplying. There's this invisible negative 1 here being multiplied by R, so I've got multiplication. So if I'm going to go in reverse PEMDAS order, I'm going to undo the addition first, and I undo plus 1 with minus 1. Do that on both sides. S over L minus 1 equals negative 1R. Okay, so I've done that, and now I can take care of undoing the multiplication by negative 1 with division by negative 1. All that's going to do, when I divide both sides by negative 1, it just changes both of the signs. So this becomes negative S over L, and this becomes positive 1, and I've got it solved for R. But if you'll do this little PEMDAS in reverse operation, I think that'll really help. Some people have trouble with these kind of problems. So here's another one. So PEMDAS in reverse. Let's see what we're trying to solve for x. X is being multiplied, and x is enclosed in parentheses. Again, I'm not going to check addition. You just want to check the parentheses, and the addition will take care of itself in the end. All right, so the way I undo multiplying by a fraction is I multiply by its reciprocal. Okay, your initial reaction is always to undo multiplication with division, and that creates a complex fraction, and we want to stay away from those. That should be equals G. Sorry about that. It's equals there. All right, so I'm going to undo multiplying by 4/9 by multiplying by 9/4. And when I multiply 9/4 times 4/9, that just creates 1. 1 times x plus 3 is x plus 3. Okay, and now all I have left is taking care of addition, undoing addition with subtraction. So these are really not too bad if you follow PEMDAS in reverse. And so there's my same equation, but now it's solved in terms of x instead of g. And that's the answer for number 10. All right, solving inequalities. Much like solving equations, we have to get rid of the parentheses first, use the distributive property. Negative 5 times 2z is negative 10z. Negative 5 times negative 11 is positive 55. Now work on getting z by itself. Subtract 55 from both sides. So this is going to be negative 71 is greater than or equal to negative 10z. So I'm going to divide by negative 10 on both sides. And by dividing by negative, remember that's going to reverse this inequality. And I get positive 71 over 10 as my answer. For graphing purposes, if you want to, you don't have to do this, but you could just turn these around. If you switch places with 7 or z and 71 over 10, then you would just turn this. Notice how it's pointing at 71 over 10. So when I turn it around, it still should be pointing at 71 over 10. And the reason why people like to do this is because when they do the graph, then they can follow the direction of the arrow, and that tells them how to shade. So 71 over 10 is just 7 1/10. All right, so I'm going to just show it like this. I'm going to say that's 7, and 7 1/10 is really just barely to the right. And so I'm going to do a solid circle barely to the right of 7. And now that I've got it turned around so that the variable is first, I can just shade the same direction that the inequality goes. So that's my answer for number 11. Okay, number 12, we need to get r on the same side. Really want to take care of this fraction. So the way you can deal with fractions like this is just multiply by the denominator on both sides of the fraction. And that will cancel, these will cancel each other, and it just leaves you with 6 minus 2r, no fraction on the right. And then on the left side, you're going to have negative 10r. Okay, so we need r's on the same side, so I'm just going to let this negative 2r get canceled and move to join this negative 10r, so I'm going to add 2r to both sides. And that gives me negative 8r is less than 6. I need to divide by negative 8 on both sides. Remember, dividing by negative means that you're going to have to switch the direction of the inequality. And this is a reducible fraction. 2 goes into both 6 and negative 8, so the reduced form would be negative 3/4. And so we sketch our graph. We'll say this is negative 1, so negative 3/4 would be about right there. And the variable's on the left, so I can trust this to tell me which direction to shade. So it's going to be an open circle, and I'm going to shade to the right, just like the inequality points to the right. Okay, here's some more. Define a variable. This time we're writing inequalities, and then we're going to solve. So for number 13, the difference of, that's subtraction of course, 3 times a number and 16. Okay, so here's 3 times a number, 16, and the difference between them, okay, is at least 8. Okay, so how do we represent is at least? So in other words, it could be more than 8, but it cannot be any less than 8. So that's another way of saying greater than or equal to 8. It could always be more, but it cannot be less than or equal to. All right, so now, or it can't be less than, it'll be more or greater. So let's solve for n. So add 16 to both sides. 3n is greater than or equal to 24, so n is greater than or equal to 8. And the directions don't say anything about graphing, so you don't have to graph these. Okay, 1/2 of a number is more than 6 less than the same number. So whenever you see 6 less than, it's talking about, in this case, it's talking about subtraction, and you should always subtract that off of the end of your variable expression. Okay, so we're ready to solve, and so I'm going to subtract n from both sides. So in terms of a fraction, this would be, right now it's negative 1 in front, so maybe we can think of it as 2 over 2. Negative 2 over 2. So 1 over 2 minus 2 over 2 is negative 1 over 2 n. And now to solve for n, I'm going to multiply by negative 2 on both sides. And again, here's that rule again. It comes up a lot. If you multiply by a negative or if you divide by a negative, you've got to remember to switch the inequality. So my solution here is n is less than 12. All right, very good. 5 less than the product of 6 and a number. All right, so let's write that part first. 5 less than means subtraction. The product of 6 and a number minus 5, basically takes care of this, is no more than twice the same number. So how do we represent is no more than? So this is kind of the counterpart to at least. is no more than would be another way of saying less than or equal to, twice the same number. All right, and so now we solve, so I'm just going to subtract 6n from both sides. And we'll divide by -4 on both sides. And once again, here it is again. We've got to reverse the direction of the inequality sign symbol. So you could write it as 5/4 is greater than or equal to n, or you could turn it around for graphing purposes. Just make sure you turn this with it. Notice it's pointing at n, it's still pointing at n. And now you can use the inequality to help you with the graph. So 5/4 is 1 1/4. So it's just a little bit, here's 1, I'll say, it's just a little bit to the right of 1. It's going to be a solid circle, and now we can see the shade to the left. All right. Okay, moving right along, we have this word problem. Manuel takes a job translating English instructions. He will receive $15 per page plus $100 per month. He'd like to work for 3 months during the summer and make at least $1,500. Write and solve an inequality to find the minimum number of pages he must translate to reach his goals. So for these word problems, whatever the question is that we're supposed to answer, and the last sentence tells us what's the minimum number of pages he must translate, that's what we need to let our variable represent. So x is going to be the minimum number of pages to translate. Okay, so based on this, x represents a certain number of pages that he'll translate. Let's see if we can make an inequality. He's going to receive $15 per page. So $15 for every page, that's 15 times x. Plus he's going to receive $100 a month, and he would like to work for 3 months. Well, we can go ahead and do some mental math. If he's going to get $100 per month, in addition to the number of pages that he translates, he's just going to get a flat $100 for every month. And he works for 3 months, that's $300. So if you take the $15 for every page he types, plus the $300 he's going to make on top of that, he wants to make at least $1,500. So the way we show at least is greater than equal to. Now he could make more. The more pages he types, the more he's going to make, but this is the bare minimum. He has to make at least $1,500. So we solve this and we'll have our answer to this question. So we just solve for x, subtract 300 from both sides. So 1,500 minus 300 is 1,200. And now we divide by 15. And we get 80. So the inequality reads as x is greater than or equal to 80. So I always like to answer word problems with words. So according to my variable, this is the minimum number of pages. So I'm going to say, to finish this off, he must translate at least 80 pages. Train yourself to always answer a word problem with some sort of phrase, word phrase. All right, there's the answer for 16. 17, we're back to these. We had some of these on the last test, so we're trying to write the equation for this line that goes through these 2 points. So first I have to find the slope, and if you forgot, here's the slope formula given 2 points. So here's the first x, here's the first y, second x, second y. So y2 is 7 minus y1 is -3. x2 is -3 minus x1 is 2. 7 minus -3 is 10 over -5. Slope is -2. All right, so we plug into y equals mx plus b, pick one of these points, doesn't matter which. We know what to plug in for slope. I'm just going to go with this one. So y equals mx, and we got to solve for b. So when I add 4 to both sides, I get b is 1. Now I'm going to write the equation to get my final answer. Y equals negative 2x plus 1. Okay, number 18 is similar, but the way we get the slope is different. We know that these two lines are perpendicular, and I know the slope of this line is negative 3/5. That means for a line perpendicular to it, it must have a slope of positive 5/3. Okay, well now I'm back to the same deal that I did before. Y equals mx plus b. I got to solve for b. Please don't take b from this line. You got to solve for b. So y equals mx and solve for b. So 5/3 times 2 is 10/3. 2 written in thirds would be 6/3. Just do 2 times 3, 6 over 3. And now solve for b. Subtract 10/3 from both sides. And you get negative 4/3 is equal to b. And now you can finish writing the equation. Y equals 5/3 x minus 4/3. All right, and that's your answer for number 18. All right, so for number 19, we're sketching the graph of this inequality. And so much like we do with lines, we start with a y-intercept, in this case of negative 3. And we look at the number in front of x, and that's a slope of negative 4. So from negative 3, we go up 4, left 1. You could also think down 4, right 1. Okay, it's going to be a solid boundary line. So I'm going to get my line draw tool ready. For you, you need a straight edge. So, oh, it'd be solid. Let me change it to solid. Try again. All right, so there's my boundary line, and now I just have to do the shading based on the fact that this is greater than, and greater than is above the line. So I'll be shading this area of my graph. All right, and so the yellow indicates all of the ordered pairs that represent where we get solutions from. So any ordered pair from this yellow area, and it goes forever and ever in that direction, but basically we're just going to indicate by shading where those ordered pairs can be found. All right, so that takes care of number 19, so let's jump over here and do number 20. Number 20 needs to be solved for y first, so we've got a little bit of work to do on this one. We're going to subtract 2x first. And then we still haven't solved for y, so remember we need to divide by negative 1. And when we divide by negative, that's going to reverse this inequality. So it looked like initially that it was going to be greater than, but as we solve for y, it becomes less than. It has to switch. So it's a little bit like this one, except it's got a positive slope. It still does have a y-intercept of negative 3, but we're going to count a positive 2 slope. So up 2 and right 1. And it's also going to be a solid boundary line. So it looks like this. And this one's less than, so less than you can think is below the line. And so my yellow shading indicates where solutions can be found. Any ordered pairs that come from the shaded region represent solutions for x and y. Okay, number 21, we have this inequality that says an artist can sell each drawing that he or she draws for $100 and each painting for $400. He hopes to make at least $2,000 every month. So let's set up a couple of variables. X is going to be the number of drawings. And Y will be the number of paintings. And so using those variables and how much he makes off of each piece of artwork, $100 for each drawing, we could say is 100x. $400 for each painting, 400 times y. And he wants to make at least $2,000 every month. So the way we represent at least is with greater than or equal to. It could be more, but it can't be less than 2,000. Okay, so that's the answer for letter A. That's the inequality. And then for letter B, we want to know if he does sell 3 paintings 1 month. So again, Y is paintings. We just put 3 in for Y and we'll solve for X, and that'll give us the answer for letter B. So 100x plus 400 times 3, and 400 times 3 is 1200. Subtract 1200 from both sides. 100x is greater than or equal to 800. So we get x is greater than or equal to 8. So again, word problems need to be answered with words. If you just get down to here, that's not really giving me an idea that you understand this, what you were doing with this word problem. So let's put some words to it. He must sell at least 8 drawings. All right, and so that's your answer for number 21. All right, so 22, we have this system of 2 linear equations, and we're told to use the graphing method. So I'll just do this top one in red. So I need to solve it for y first. Y is equal to negative 2x plus 5. So we start with a y-intercept of 5. And we have a slope of negative 2. So down 2, right 1, up 2, left 1. We get our straight edge, and we draw this line. And solving by graphing means that we're basically going to sketch each line, and we hope they cross. So I'll do this one in blue. Solve for y. It's going to be y equals x plus 2. Start at 2 on the y-axis, slope of positive 1, straight edge, so there's my blue line, and my answer, if I do have a solution with the graphing method, it'll be where these 2 lines cross each other, and it looks like they cross at x equals 1, y equals 3. So that's my ordered pair represents the solutions for x and y. Oh, and I think your follow-up instructions here were to prove this answer using substitution or elimination. I'll just do both. All right, so let's start with substitution. Since these are both solved for y, substitution says solve for a variable, okay? Down here in the blue, I've solved for y, and then replace that variable in the other equation. So let's see if we get the same answer. So I've replaced the top y with x plus 2, and using the substitution method, do we get the same answer that we got with the graphing method? All right, so solve for x. So I'm going to add 2x to both sides. 3x plus 2 is equal to 5. 3x is equal to 3, subtracting 2, x equals 1, that checks. And now I can find y, doesn't really matter which one I pick, if you let x be 1 in the bottom, you get the y. So checks out with substitution. Now let's say you chose elimination on your test to prove that your graph was right. So elimination says to pick a variable to eliminate, and the way it's set up, I could eliminate y just leaving it like it is and subtracting, because y minus y is 0. So if it takes subtraction to eliminate y, then I have to subtract everything. So 2 minus negative 1 is 3x, y minus y is 0, 5 minus 2 is 3, x equals 1, there we are again, and then we know how to find y. Let's go to the other one just to make it interesting. Y equals negative 2 times 1 plus 5. Negative 2 plus 5 is 3. So I proved it. I got an answer with graphing, and I feel really confident that the graph is correct because I proved it, got the same result with substitution and with elimination. Okay, here's another substitution problem. So substitution says pick a variable, solve for it. The easiest choice, if you have it, is to pick a variable with a coefficient of 1. So on the bottom equation, if I solve for x, just add 3y to both sides. I get x equals 3y plus 3. So you solve for a variable, and then you replace that variable in the other equation. All right, and so now we just solve for y. Negative 6y minus 6 plus 5y equals negative 2. Negative 6y plus 5y is negative 1y. Add 6 to both sides and divide by negative 1 on both sides. Okay, so I got half of my answer, and I can use this equation here inputting negative 4 for y, and I can get x. It says x is equal to negative 12 plus 3, so x is going to be negative 9. And that's my answer for 23 using the substitution method. So here's another example of solving a system, but this time it's using the elimination method. I'm going to eliminate y by multiplying the top equation by 3 and the bottom equation by 2. Okay, the top equation multiplied by 3 all the way across is 15x minus 6y is negative 57. By 2 all the way across on the bottom, it's 4x plus 6y equals 0. And I can add these like terms together, and I'll eliminate y. So 15 plus 4 is 19x. And negative 57 plus 0, and then I divide by 19 on both sides, and I got x is negative 3. So now I can solve for y by choosing either one of these. I'll just go with the bottom one. 2 times negative 3 plus 3y is 0. Negative 6 plus 3y is 0. 3y is equal to 6, so y is 2. And you'll need to show your answer as an ordered pair. The answer is x is negative 3, y is 2. So that's the elimination method. Okay, here's an example of you coming up with the system, given a word problem. Okay, so a system in this case represents two different linear equations. So one of my equations will represent the cost for using fix-it-fast plumbing. Okay, I'll just do this. My equation to represent fix-it-fast, and then we have another equation for do-it-right. Okay, so what we know is they each have a separate way of charging for the work that they do. The question to be answered is how many hours must be spent on the job for the two companies to charge the same amount. All right, so remember, when you set up a variable, it should answer the question. Okay, so the question is how many hours must be spent on the job. So X, my variable, is going to represent number of hours spent on the job. Okay, so for fix it fast, let's add one more variable. Y is going to represent how much they charge, dollar amount charged. Okay, so fix it fast, they charge based on $50 for each hour spent on the job, 50 times X, in other words. And then just for showing up, maybe they don't even do any work, but a lot of these companies are going to charge you what they call a house call just for coming and talking to you about doing the job. So even if X is 0, they don't spend any time working, they're still going to charge you that $25 for coming to your house and giving you some information about the job. Okay, it's called a house call. Okay, so that's fix it fast. Do it right, their charge is a little bit different. They're going to charge you $35 for the house call and then $45 for each hour spent. So it's a little bit less per hour, but it's a little bit more for the house call. Okay, so we've got the system. The last sentence says write a system of two linear equations. All right, we've done that. And now solve with your preferred method. And that means you can use either substitution or elimination. I mean, theoretically, you could use the graphing method, but not many people like to graph. So I'm going to use substitution since these are both already solved for y. I can let this 45x plus 35 replace the other y up here, and I can solve for x that way. So 45x plus 35 equals 50x plus 25. And solving for x, I'm going to subtract 45x from both sides. And 35 is equal to 5x plus 25. 5x is equal to 10, so 2 is equal to x. So we just answered the question, since x represents the number of hours spent on the job, the answer to the question, how many hours must be spent for the two companies to charge the same amount after 2 hours of work? Each company would charge the same amount. So in other words, if you knew you had a 2-hour job that needed to be done, you knew it was going to take 2 hours, it really wouldn't matter which one of these you chose. They're both going to charge you the same amount. All right, that's the answer for 25. 26, this is a system of inequalities, and so here's how we solve those. I'll just go ahead and do this one in blue. It has a y-intercept of -6. And a slope of +3, up 3, right 1. It's going to be a solid boundary line. So that one looks like that. And when I do the shading, less than is below the line. So we'll just indicate a little bit of shading like this. This is how we'll shade the blue, below the line. Okay, maybe do the other one in red. It has a y-intercept of +2. Y-intercept +2 and a slope of -4. So up 4, left 1, or down 4, right 1. And it's going to be a dotted boundary line. Looks like that. And it's the greater than side, so greater than is above the line. So what we're interested in is where the two shadings collide below the blue, but at the same time above the red. So we're talking about, I'll just do it with this color, everything above the red dotted, but at the same time below the blue solid. So that represents this overall solution to the system. Okay, and we're almost done. We got some factoring to do, and then that will take care of it. So with factoring, we always look for a GCF first. Number 27, I don't see a GCF. So trying to factor it as two linear binomials multiplied together. Linear means that we're going to have x to the first in each group. X times x gives you x squared. I need the factors of 24 in the second slots, but I can't just pick any factors of 24. I need the factors of 24 that add up to 10 in this case. And the factors of 24 that add up to 10 are 6 and 4. Notice how multiplied gives you the last number, added gives you the middle number, and so that tells you what the factoring should be. And you could use FOIL to check it out. Number 28 is a box method problem. So here's how the box method works. First term, last term, multiply those together, and then find factors of this product that add up to the middle term. That's going to be 8x and negative 7x. Fill in the other two squares, and now find 4 GCFs, and you'll have your factoring. So going across this way, it's 2x. Going across this way, it's negative 7, so those represent one of my factors. Going this way, it's x, and this way, it's 4, and that represents my other factors. That's the answer for 28. For 29, I notice that there's a GCF. You should always look for GCF first. X squared plus 2x plus 3. Looking inside the parentheses, seeing if more factoring can be done. There aren't any factors of 3 that add up to 2. They have to be positive, and there's no way to do that. So that's it. That's my factoring. I'm done. I can't go any further. Number 30 is the example of the special factoring case, the difference between two perfect squares. So if you recognize those, it's really nice to factor these. Just write the square roots twice, and one is plus and the other one is minus. That's it for number 30. 31, again, we're looking for the factors of negative 12 that add up to negative 4. We don't have a GCF this time, so those would be minus 6 and plus 2. And then finally, looking for GCF, don't see one, so this is going to be another box method problem. 3x squared negative 16, multiply those together. Now search for the factors of negative 48x squared that add up to positive 8x. And that's going to be 12x and negative 4x. And now find your GCFs. Going this way, 3x. Going this way, it's negative 4. Well, there's a factor. Going this way, it's x. And going this way, it's 4. And once again, if you have time on your test, you can always use FOIL and check these out. Okay, I think that does it. And so I hope this helps as you prepare for your test. If you have any other questions, let me know.